know you want to watch the games. Okay. So, no, I said I had to finish it. I said we'd either finish it today or Friday, and I could do a little bit each day. Now, I want to talk about what you have to know about polars. Oh, there it is. I firmly believe I know you'll have one at least of the multiple choice if you don't have it elsewhere. So, I want to get to the basics of what you need to know. No, I finished that yesterday. This is the blue one. Okay. There's just not a lot of stuff you have to know, but we got to know some basic things. Okay, guys, ready? Okay, the sooner we get going, the sooner we're done. This is the radius, this is x, and this is y. You need to be able to convert between polars and Cartesians because sometimes they mix them up in a problem. So I know that the cosine of theta is what? X over r, which means that x equals r cosine of theta. Okay, guys? Okay, in the back? Then the sine of theta equals y over r, which implies that y is equal to r sine theta. Okay? Okay, Chris? So what's the tangent of theta? Look at the diagram, or you can ratio these. It's y over x. And one last thing, x squared plus y squared is equal to r squared. That's the equation of a circle. It just comes from Pythagorean's theorem. Now, if you know that, that's huge, because often on the exam, you will get a point for just writing those things. X equals r cosine theta, y equals r sine theta. So if they were to ask you, for the slope of a tangent line, so I'll just draw a line here. I want the slope of that. What do I need to know? I need to know the point, and I need to know dy dx. Maybe I do like it like this. How are you going to find dy dx? Remember, in parametrics, it's dy dt, or d theta in this case. Is that d theta? Oh, don't mess me up. Yep, it's d theta. Yeah. Why would I ever second guess you? Over dx d theta, right? So you are going to have to take the derivative of these things. Well, that's what I do on this this slide right here. dy dx is this. Now, if y equals r sine theta, what's dy d theta? This is the hard part right here. It's not just r times the cosine of theta, is it? I have to use the product rule. That's, to me, not intuitive because I'm not used to the fact that r is changing. R is going to be some function of theta. So if I had written this r of theta times the sine of theta, it would be easier to do. Okay, that's the reason why I wanted to talk to you about that. It's a variable. So it's r times the derivative of the sine, cosine of theta, plus the sine of theta times the derivative of r with respect to theta. Now, I don't want to memorize that. Do you want to memorize? I don't want to memorize. That's too hard. So if I want to do x equals r cosine theta, I mean, you could put it in the memorizing pile, but that's too hard. I want dx d theta, which is r cosine theta, plus the, sorry, I forgot to differentiate the cosine. What's the derivative of the cosine? Negative sine of theta plus the cosine of theta times the derivative of r, which is what? dr d theta. So if I wanted to put them into the fraction, I could. This would go here, this would go in the numerator, and that's how I find dy dx. I have to know a lot of stuff, though. Now, r is going to be a function of theta, usually. Maybe it's 1 plus the sine of theta. I don't know. But to me, it was like, oh, if I want to find that, just take the derivative of r. No, I don't. Okay, how do you find horizontal tangents, then? Nick, how do you find, this is all BC. How do you find a horizontal tangent? dy dx. If it's a horizontal tangent, dy dx equals what? So therefore, dy d theta, guys, is equal, I'm almost done, actually, is equal to 0. How do you find vertical tangents? dy dx is undefined. Think of these as parametrics. You've got 3 variables here. So which one is that one? dx dt, I'm sorry, d theta is 0. Okay? You have to know, if you know the basic stuff that I put over here, if you know that, and one other formula, which we're going to do, you're going to be in good shape. You can do the examples if you'd like. And I think maybe tomorrow we should do them because the cardioid is kind of hard. And what about polar curves? What about areas? So I'll leave those open for you to try. Okay, there's my regular curve. I want in polar coordinates. I want the area of this little sector. Because they're going to give you a polar curve. Honestly, I don't know. I'm sure that there are things that can be described in polar curves. Probably a weather system. Okay, the request is to go back. That's the basics. Okay, guys? There's one other formula I got to add in here, and it's the area of the region. That's it. Okay, do you have this written down, you guys? Because if you have this, you have polars. Yesterday, what we did is we graphed them because you have, you guys, Zach, you have to be able to look at a graph, and when you are doing areas under curves, you have to know where you're going to integrate from. And if you don't know how to graph polar coordinates, you can't figure that out. That's why I did it by hand. Usually, it might be a graphing calculator problem, it might not. If it's not, then they will give you the picture of the polar curve. And I've got all sorts of slides here with all the polar problems. We need to do all of them. That's not a lot of practice. We need to do all the AP polar problems. And I thought last year we'd have a polar curve, and we did not. I'm thinking it's just going to happen. And if it's not this year, it will be probably for sure the next year. It's got to be coming up. It's been, I know, you won't have to worry about it. We will prepare for both parametrics and for polars. Because guess what? If I change theta to a t, I'm now in parametric mode. So it's the same equations, isn't it? Okay? So let's do a polar curve. Now, I want the area of this little sector. Do you remember sectors in geometry? What is a sector? You guys, what is a sector? A sector is, it's a bisector, right? It's part of this, hey, guys, I'll be done so much faster if you're quiet. Then you can be making noise. It's the area of that region right there. So if I took this region right here, what part of a circle is that? Quarter. So it's theta over 360 degrees. It's what part of the circle, that'd be 90 degrees over 360 times pi r squared. That's the area of a sector in degrees. But I want to change it to radians. Okay, Eric, do you remember? Now, This is degrees. I don't want to be in degrees. We want to be in radians. So we're going to take our angle. How many radians in a full circle? 2 pi times pi r squared. I'd like to see that because then it makes things make sense. Because you're going to say, where did you get that formula? What happens to pi's? They cancel. So the area of a sector, just one sector, is theta over 2 r squared. Okay, Eric, what am I going to do with this? Not derivative. Now, I got to get a differential in here. What's really tiny when I do my sectors? The theta or the r? Theta. Guys, you can do that in like 2 minutes. Theta is what's really small, so we're going to make that delta theta. If we make it small enough, so the area is going to be equal to 1/2 r squared delta theta. Does that make sense? Because we're making this angle small, not the radius. And so what are we going to do to find the total area? We are going to integrate it. It's r squared d theta from theta 1 to theta 2. Now that seems like it's pretty easy, but the problem is figuring out where your angles are. This is the one in polars. You know what? I'm even going to go back and put it on the page with everything you need to know about polars, because then it's complete. Now, that's assuming you know how to find dy dx. You know your parametrics. So the area of a polar region is the integral from theta 1 to theta 2, and it's 1/2 r. I like to put that outside. I don't have to, d theta. And I'm sure on Monday or even tomorrow somebody's going to come back and say, where'd you get the 1/2 r squared? Why do I show you where it is? Because if you're on the exam and you forget what it is, maybe if I understood it to begin with, you can come back and pull it out again. So, we could do this one, and the angles are the hard part. So we either can do number 2 or I can just let you work on it on your own. And then I've got a whole bunch of examples here on the smartboard. You have to make it. Now, you may use your graphing calculator right now, but on the exam, this is a non-calculator problem. You are expected to know how to graph that. We just did it yesterday. If r is equal to 2, what is that? Circle of radius 2. What if r is equal to 4 sine theta? Do you remember what that is? That's a circle. Now, because it's sine, it's on the y-axis. So it's up here. And if theta is equal to 90 degrees, okay, theta is equal to 0. What if theta is equal to 0? Then r is equal to 4 times the sine of 0. R equals 0. So you're going to rotate 0 degrees. You're going to make r equal to 0. You're at the origin. What if theta is equal to pi over 2? Now you're going to rotate through this 90 degrees. How long is the radius there? Now I shouldn't say radius. R is equal to, well, it is 4 times the sine of pi over 2. So that's just 4. So this is 4. So what's the radius of this circle? 2. I want to find the area trapped between the two curves. Oopsie, I got to get used to this. Yeah, I want the area that's bounded above by this one and below. I don't have it written down correctly. I didn't type it off the exam, which I should have, because it's exactly a question on the exam. So what do you think you're going to do there? Well, just like you've done with other areas, I have to integrate, but I want the shaded region. So I'm going to take the area of r equals 4 sine theta and then subtract off what? This area of the sector from that one to that one, right? Subtract off the area of r equals 2. I'm going to integrate. If I get my, this is why I say it's hard. If I get my angles correct, that's going to be the hard part right there. And if I integrate this, it'll give me this sector right there. Let me get a different color. Oh, I'll put the crayon. It'll give me this. And then if I subtract out, I'll try to do this. Let's try red green. And then if I find this area, I'll be left with the yellow area. That's what the question's asking. It's not framed right. I didn't type it up correctly. And do what? No, we have to find the angles. What angle? I'm going to only integrate it from here to here, or I could do it by hand. That's what we need to do is we need to find the angles. Yeah, I actually just did it, but so let's get it set up and then we'll find the angles. So the area of this one is 1/2, guys, theta 1 to theta 2 of r squared 4 sine squared of theta, whoops, put the 2 in the wrong place, squared d theta minus 1/2 the integral of that radius, 2 squared d theta. Now you could do this with geometry. We have to figure out what that angle is, don't we? Remember how to find the angle? I want these two curves to do what? Intersect. So 2 is equal to 4 times the sine of theta. Now, you know they're going to give you 30, 60, 90s, or 45, 45, 90s if it's not without a calculator. So 1/2 is equal to the sine of what angle? Yep. What angle is that? Nope. The sine of my angle is 1, 2. This is square root of 3. So this is 30 degrees. I honestly do that in my head. 30 degrees, which is pi over 6. Otherwise, I get the wrong one. So this is pi over 6. You know what? I'm going to just write it down here. Theta 1 is equal to pi over 6. Can you use a little symmetry to tell me what theta 2 is? Where else is the sine equal to a positive 1/2? Let's draw our quadrants. This is pi over 6. That's 30 degrees. I want the sine to be, the reference angle is still pi over 6. So how many pi over 6s is it? 1, 2, 3, 4, 5. You see that? Now, do you remember all the trig functions are positive here? Sine, all students take calc. The sine is still positive. If I go to this quadrant here, it's not positive any longer. So I have two answers to this equation. I have an infinite number of answers because I could go around the circle more than once. So this is 5 pi over 6. And that's the answer. Now, one last thing. Could you find the area of this little slice of the pie? If this is 30 degrees and that's 30 degrees, that's 60. What's left? Let's use degrees because I understand degrees. If you've used up 60 degrees out of 180, it's 120 over 360 pi r squared. What's the radius of that guy? It was 2, right? So that's 1/3 of 4 pi. So that's 4/3 pi. If you integrate this, you should get that. You want to do it? Or do you believe me? Right. Did I lose my minus sign? Sorry. I lost my minus sign. So I take the area of the big one minus the area of the little one. And you know what? It doesn't get any harder than that in the multiple choice. Okay, you guys, I'll pull up all the polars for multiple choice. Make you a handout on that, okay? You could find them. I've given them all to you. Oh, and there is a mistake here. Yeah. It's the same. Where they intersect. because it's where they intersect. Okay, guys, this one is typed in here wrong. This is 2007, number 3. And then, and you should try these. They're not easy. There's one. That does not look easy to me. You've seen it, actually. Okay, you guys, girls. This is 2009 Form B. I have to go to the Form Bs to get enough examples. There aren't enough. But see how this crazy thing is? You have to figure out where that is. You need to know what the angle is and what R is to get there. Read the problem, you'll see. So that's why we have to know how to graph these things. And it says find dx d theta and dy d theta. Well, you know y equals what? R sine theta. Can you find dy d theta, or are you going to memorize that formula? Okay, guys? No, you're going to do the product rule. But you have to remember it's the product rule. And what about dx d theta? X equals r cosine theta. I just did that. That's worth a lot of points for B. And A is actually pretty easy. B, okay, you guys? B is worth 4 points. All you have to know, look at that, I get a point for that. How easy can you get? But it isn't going to feel easy. Abby? Back to, yes. I subtract them. Did I lose it? We can do that because you guys want it to be done. And guys, I can't do anything if I don't hear. I take this area, it's a sector divided by that one. Actually, I find this, this area of this whole thing divided by this piece, not divided by, subtracting that piece, I'll be left with the yellow. It's just geometry. When you do this one, you have to graph it. This is polar area. Oh, why don't we let you try these? No? Where's example 2? That's example 1. Oh, yeah, that one, you just find dy dx. And then this is dy d theta equals 0. And this is 1/2 r squared d theta from theta 1 to theta 2. I feel like I'm missing an r there. Yes, I typed this wrong. This should be r equals 2 cosine of 2 theta. There, that'll make it feel better. Okay? Try it. And tomorrow we can come back and actually do it if we need to. And then the other thing to do is to work on the AP problem.